This is Math 6, Lesson 3-2, Variables and Expressions. A numerical expression is a mathematical phrase with only numbers and operation symbols. Much like English, if you do not have a subject and a verb, it's just a phrase. If I said around the corner, that would be a phrase in English. It doesn't have a subject and it doesn't have a verb, so it's not a complete sentence. In mathematics, if we have a phrase, it's called an expression. An expression does not have an equal sign. For example, 8 plus 5 minus 2 is an expression. X minus 6 is also an expression. A variable is a symbol that can represent one or more numbers. Variables are usually letters. Letters like X, T, Y, M, etc. Notice that when I do my X, I don't make it look like the multiplication symbol for X. I give it a little script look so that it does not get confused with the multiplication symbol. Notice how my T has a tail on the end, so it doesn't get confused with the addition symbol. Variables you will avoid are variables like L if you can, because it looks like a 1. You avoid O because it looks like a 0. And we avoid the lowercase letter I because many times that has a different reference that you will understand later when you get into a class called Algebra 2. An algebraic expression is a mathematical expression with one or more variables, like x plus 6, or 3x squared plus 2x minus 9. Those are mathematical expressions. Notice how they do not have an equal sign. That's what makes them an expression and not an equation. To evaluate means you're going to replace each variable with a number and then use the order of operations to simplify the expression as far as you can go. Sometimes that simplification will mean that you will get an actual answer, like 6. Sometimes you will not. We're going to model with algebra tiles for a moment. Now obviously you're probably not going to carry little plastic tiles in your pocket, but it is nice to understand and see a visual representation of what variables and numbers look like. You can use algebra tiles to model expressions. A small yellow square will represent the number 1, and a long green tile will represent a variable. Now obviously if you don't have colors, you can just realize that a long green bar, a long rectangle, is a variable and a square is a number. So if I was going to model the expression 2x plus 3 with algebra tiles, I would realize, well, x is the long rectangle, and I have 2 of them because it says 2x right there. So I'm going to draw a long green rectangle. I can even shade it in if I want. I can draw a second one because I have 2 of them. Okay, the first one stands for 1x, the second one stands for the second x. So there it becomes 2x. And then I have a 3 right here, which means I need 3 yellow squares. There's 1, there's 2, and there's 3. If I wanted to, I could color them in with yellow. Like so. And that's the expression 2x plus 3. So if you see something with tiles, you should be able to read what the expression stands for. To evaluate an algebraic expression, you simply want to place the number in for the variable and then do what the operation says. In this first problem, we have 3x plus 15. A number next to a variable means I'm going to multiply. This means 3 multiplied by x. Now you can see why those multiplication symbols are really hard. So which is why I oftentimes do not use the x as multiplication. When I'm dealing with algebra, I will use the parenthesis. Like so. So that means whatever I put in for x, which in this case has to be 7, that means I'm going to do 3 times 7 plus 15. That's what this algebraic expression says. It says 3x plus 15 when x is 7. So 3 times 7 plus 15. Order of operations says I need to multiply first. So 7 times 3 is 21. And then I need to add my 15. 21 plus 15 is 36. Number 3 here says 5x divided by 7, which means I'm going to take my 5, multiply it by my 7, and then divide by 7. 5 parentheses 7 divided by 7. Please avoid the x as a multiplication symbol. It will be very confusing with the variable x. So my order of operations says I should multiply first, so 5 times 7 is 35. 35 divided by 7 is 5. Number 4 says 56 minus 4x. So 56 minus 4 times 7. So I have plugged my numbers in. Now I need to work through the problem. The first step every time you evaluate an expression is to plug the numbers in for all the variables. And sometimes you'll have more than one variable in an algebraic expression, so you may have to plug in more than one set of numbers. Order of operations says I should multiply first, so I'm going to have 56 minus 7 times 4, which is 28. And 56 minus 28 is 28. So my answer here is 28. Notice how on all three of these problems, when we simplified, we actually got an answer. So the word evaluate, the word simplify, can also mean the same as solve. If I simplify down to a number, I've solved it. If I evaluate down to a number, I've solved it. Not always will you be able to get it down to a single number. So that's why they use the terms evaluate and or simplify. You can evaluate an expression using one or more values. Okay? Make a table to organize the different values. Let's take a look at this problem. It says the cost to rent a canoe at the lake is a $6 basic fee plus $4 each hour H that the canoe is rented. The expression for the total cost of a canoe rental is $6 plus $4 H. Copy and complete the following table. So, if I wanted to make sure that my patrons who wanted to rent my canoes knew how much it was going to cost them, I might put up a little sheet. I might explain that, oh yes, to rent the canoe you have to pay a $6 fee just to rent the canoe, and then it's $4 for every hour that you use my canoe. But some people may not want to have to try to figure that math out, so perhaps I want to make a sign for them so that they'll know how much money they're going to spend. So what I'm going to do is I'm going to figure out what it's going to cost for the couple of hours that somebody may want to rent a canoe. So if they want to rent a canoe for 1 hour, I would do 6 plus 4 times 1. Well, 4 times 1 is 4. 4 plus 6 is 10. So it would cost them $10 here. If they rented a canoe for 2 hours, that would be 6 plus 4 times 2. That would be 6 plus 8. And 6 plus 8 is 14. So it would cost them $14 to rent a canoe for 2 hours. For 3 hours, it would be 6 plus 4 times 3, which is 6 plus 12, which is 18. So for 3 hours, it would cost them $18. So as you can see here, you can use a table to figure out an expression just as much. It's just this way we found several values for the same expression, substituting in different values for H each time. And this is the end of lesson 3-2.